Dear learners, welcome to the module on Python classes. So far, we have seen the basic Python constructs and written simple programs using them. In this session, we are going to study about the object oriented capability of the Python language. As already said, Python is an object oriented programming language. Object oriented programming, in short referred as OOP, focuses on creating reusable patterns of code, in contrast to procedural programming using C language, which focuses on functional units of a program. When working on complex programs in particular, object oriented programming lets you reuse code and write code that is more readable, which in turn makes it more maintainable. One of the most important concepts in object oriented programming is the classes and objects, which are defined as: class is a blueprint created by a programmer for an object. This defines a set of attributes that will characterize any object that is instantiated, that is also called created from this class. Object is an instance of a class. This is the realized version of the class, where the class is manifested in the program. These are used to create patterns in case of classes and then make use of the patterns in case of objects. In this module, we will go through creating classes, instantiating objects, initializing attributes with a function called the constructor method, and working with more than one object of the same class. Now, we delve more into the classes. Class is like a blueprint of a prototype that you can define to use. We define classes by using the class keyword, similar to how we define functions using the def keyword. Let us define a class called horse that has two functions associated with it, one for running and the other for being awesome. So, in this slide, please see that we are creating a class by the name horse. So, we say use the keyword class, then followed by horse. Horse is the user defined name that we give. In this case, we are calling it a horse for the which refers to the real world entity horse. The beauty of object oriented programming is that any problem, whatever complex, can be decomposed into a set of objects that interact with each other. Objects interact with each other by calling methods from one object, that and those methods are called, in some programming languages they are called member functions. So, an object calls the method of another object, and the other object may call the method of some other object. So, in this way objects interact with each other using method calls. So, in our case we have a class called horse, and we have defined two methods in this class. One is runs, because you know that horse actually runs. So, we have a method called runs, def of runs, and then you know that horses are very handsome, or sometimes we call awesome. So, we have another method be awesome, that is again another method for the horse. So, to make the explanation simple, so our example contains only two methods. Now, you see that in both the method I have passed a object called self. So, self, what is self? This keyword. So, the self keyword refers to the instance of the, that is the object of the class, what we are referring to. In this case, self refers to the instance of the horse class. Now, in the runs method, it simply says it is a behavior, the horse runs. So, the def runs, I print the horse is running, and in the def be awesome, I simply print the horse is awesome. Because these functions runs and be awesome are intended under the class horse, they are called methods. Methods are special kind of functions that are defined within a class. The argument to this method is the keyword self, which is a reference to the objects that are made based on this class, that is horse. In languages like C++ and Java, this keyword is used for self to reference, that is point to instances or objects of the class. Self will always be the first parameter, but it need not be the only one. Defining this class does not create any horse objects, only the pattern for a horse object that we can define later. That is, if you run the program above, at this stage nothing will be returned. Defining the horse class did not create any horse objects, only the pattern for a horse object that we can define later. That is, if you run the program at this stage, nothing will be returned. Creating the horse class provided us with the blueprint for an object. Now, what are objects? An object is an instance of a class. We can take the horse class, what we defined just now, and use it to create an object or an instance of it. We will make a horse object called horsey. So, that can be done by horsey equal to horse open close parenthesis. Here we initialized the object horsey as an instance of the class by setting it equal to horse. Now, let us use the two methods with the horse object called horsey. Please refer to the figure. Now, here in this slide I try to access the methods. So, now the first line you see that I first instantiate an object called horsey. So, I say horsey equal to HORSE horse. So, horse is the name of the class. So, horse, then I use the open close parenthesis, then I say assign it to horsey. So, this is the syntax for instantiating an object of the horse class, and it is called horsey. Now, I use the dot operator and call the methods horsey dot runs open close parenthesis, then similarly horsey dot be awesome open close parenthesis. As you know, runs and be awesome are the two methods that we have already defined inside the horse class. The horse object horsey is using the two methods runs and the be awesome. We call these using the dot operator, which we use to reference an attribute to the object. In this case, the attribute is a method and it is called with the parenthesis, like how you would also call with a function. Because the keyword self was a parameter of the methods as defined in the horse class, the horsey object gets passed to the methods. The self parameter ensures that the methods have a way of referring to the object attributes. When we call the methods, however, nothing is passed inside the parenthesis. The object horsey being automatically passed with the dot operator. Now, let us now add the object within the context of a program called horse.py and run the same. In this diagram, you can see a listing of a code that we have written for demonstrating the object oriented programming capability of Python. So, a program with a class definition is shown here. So, I have created a class called horse, what we have already done with two methods runs and be awesome, and both the methods take self as the parameter. This we have already done. Now, I create the main method def main, wherein within the main method I create an object, and the object is horsey, HORSIE, equal to horse. That this statement creates an object called horsey based on the class horse. Now, I simply use the dot operator to access the methods runs and be awesome, and horsey dot runs followed by horsey dot be awesome, and when you execute this program, the output appears as shown in the figure. So, slide 5 shows the output of the previous program. So, here we can run the program using the Python command python space horse.py, and you get the output, the horse is running, the horse is awesome. So, how does the sentence, how does the line horse is running gets printed? It gets printed as a result of running the function horsey dot runs, and the next function what we have accessed is horsey dot be awesome. So, that prints the horse is awesome. So, these are the two lines that are printed as output of the program what we have seen. Now, let us review what the so called constructor method is. The constructor method is used to initialize data. It is run as soon as an object of the class is instantiated, also known as the init method. It will be the first definition of the class and looks like this. Please see the figure. In this diagram, you see a listing of the program. So, where we have defined a class called horse, but this time the change is that we have added a init method to the class horse as the first method, and the other two methods remain the same, that is the runs and the be awesome. And the main method, there is no change, has the same three statements what we had before, horsey equal to horse, that is creating an object of the class horse by the name horsey, then accessing the runs method and the be awesome method using the dot operator. Now, when you run this program, what you find is the output as shown in the figure. You see that the first line of the output is this is the constructor method of the horse that is printed. So, but we have not made an explicit call to the init method, but that is the method that is actually being executed first, followed by the other two methods, that is runs and be awesome, which we have called using the dot operator. So, this init method is the constructor method that is automatically called when the object is instantiated. Now, if we add the init method to our horse program and run the code, the output will appear as shown in the figure what we have seen now. Now, let us make a small modification to the program as shown in the figure. What we are going to do is sending a string argument to the constructor method. Please observe very carefully. In this diagram, please observe that we have created a class horse and we have made a small modification to that class, that is we have added another parameter, we are passing another parameter to the init method in addition to the self object. So, def init, first parameter is the self object followed by name, a name is a string. So, here that name is assigned as a property, as an attribute of the self object, self dot name equals name. So, we try to assign a name to the object in the parameter in the constructor. Then the other two methods, the small changes are made. In the runs method, we print, now instead of simply saying the horse is running, now we print it as self dot name is running. So, here we are trying to access the name of the object using the self keyword, self dot name is running. And similarly, in the awesome method also, instead of saying the horse is awesome, now we are going to replace that horse with the name of the horse, which we try to access from the self object, self dot name plus is awesome. We are trying to print that, and is the main method. In the main method, you see that we create the horse object called horsey, but this time you see that we are passing a string parameter to the horse instantiation. So, here we use horse open parenthesis close parenthesis, within that we pass a string called horsey, and that string gets assigned as a name to the horsey object. Then we say horsey dot run, then we say horsey dot be awesome. So, this is the only changes that we have made compared to the previous program, and now you see the output what you get as you run the program. Now, you see instead of simply getting the horse is running or the horse is awesome as we got before, now what we display, what we get as the display is horsey is running and horsey is awesome, where horsey is the name that we have assigned to the object what we have created. We see that the name we pass to the object, that is string horsey, is being printed out. We define the init method with the parameter name along with the self keyword and defined a variable within the method. Because the constructor method is automatically initialized, we do not need to explicitly call it, only pass the arguments in the parenthesis following the class name when we create a new instance of the class. Suppose we want to add another parameter such as age, we could do so by also passing it to the init method. So, in this slide you see that we have made still another change to the same class horse. Now, you see the class horse with the init method. So, now there are 3 arguments, that is the self object, the first argument, the second the name what we have used in the previous discussion, and the age. Now, we had add one more parameter called age. Now, what we do is we assign the name and age arguments to self dot name and self dot age respectively. So, where age, name and age, they refer to the attributes of the object horse. Then here we make one more change to the main method. So, that is at the time of instantiating the horse object. So, the line horsey equals horse, initially we sent only the string horsey as an argument, but now we also sent something numerical value called 5 in addition to the string. So, the statement looks like horsey equals horse of horsey comma 5, where 5 refers to the age of the horse in years. Now, what we have done is actually created a horse object called horsey, whose name is horsey and whose age is 5, and this can be accessed by any of the methods whatever we choose as per the design of the program. Now, how about creating and working with more than one object of a class? Classes are useful because they allow us to create many similar objects based on the same blueprint. To get a sense for how this works, let us add another horse object called Stevie to our program. So, here you see the same horse object what we have done before, and here we have simplified it, the constructor method init method with only one parameter, that is name. So, the init function has the self object and as well as the name, and we assign the name as name to the self dot name. Then the runs method and the be awesome method are similar to what we have done before. So, instead of so we want to print who is running, say self dot name, we want to print the name of the horse that is running and the name of the horse that is awesome. So, that is the change, and in the main method in that diagram, now you can see that now we are creating 2 objects in the main method. So, horsey equals horse of horsey, that is HORSIE, that is the name string we are passing on to the horse method. Then we simply print for horsey object, we print we access the method be awesome. I say horsey dot be awesome, and I create one more object called Stevie, Stevie equals horse of, and I pass an argument string called Stevie, Stevie, and then for Stevie object I simply call the runs method and run the program. What do you observe? For the horsey object we have printed, it prints horsey is awesome because we have called only the function awesome method, horsey dot be awesome. So, it prints horsey is awesome, whereas we created one more object called Stevie, and for the Stevie object we call the runs method, and when we did that, the next line that is printed is Stevie is running. So, you see that now how we are able to create two objects of the same class horse. So, this is a simplification for understanding purpose that I have created only two objects, but in fact in object oriented programming, depending upon the complexity of the problem, you can have multiple classes and multiple methods that can interact in a complex way. In short, we have created a second horse object called Stevie and passed the name Stevie to it. In this example, we use the be awesome method with horsey and the run method with the Stevie object. Now, it is time to conclude this module. In this module, we went through creating classes, instantiating objects, initializing attributes with the constructor method, and working with more than one object of the same class. Object oriented programming is an important concept to understand because it makes code reuse more straightforward, as objects created for one program can be used in another. Object oriented program can also make for better program design, since complex programs are difficult to write and require careful planning, and this in turn makes it convenient to maintain the program over time. We will see many more of the object oriented programming features in Python in our forthcoming modules. Thank you.